Okay, so a special electronic sensor is embedded in the seat of a car that takes riders around a circular loop-de-loop ride at an amusement park. The sensor measures the magnitude of the normal force that the seat exerts on a rider. The loop-de-loop ride is in the vertical plane and its radius is 21 meters. Sitting on the seat before the ride starts, a rider is level and stationary, and the electronic sensor reads 770 newtons. At the top of the loop, the rider is upside down and moving, and the sensor reads 350 newtons. What is the speed of the rider at the top of the loop? So, at the bottom of the loop, we know the radius is 21 meters. The velocity is 0 because it is stationary, as it says in the problem. And the weight, or the mass times the gravity, is 770 newtons. So, to find so we should start out by finding the mass of the rider instead of the weight. It will be a lot more practical. So 770 divided by the force of gravity, which would give us 78.49 kilograms. So we know the formula for centripetal force, which is mass times velocity squared divided by r. So we have all of those components at the moment except for the centripetal force and the velocity. Now the velocity is what the question is asking for. So let's start out by trying to find the centripetal force. So we know the net force is equal to the centripetal force plus the force of gravity, because those are the only two forces acting on the object, or on the rider, rather. So we can manipulate that formula into reading the net force minus the force of gravity is equal to the centripetal force. Now we know the net force, which would be 350. Let me erase that. 350 minus 770, which will give you the centripetal force. And that centripetal force would be equal to negative 390 newtons. Okay, so now that we have the centripetal force, we can finally use the equation mentioned previously, which is the centripetal force is equal to the mass times the velocity squared divided by the radius. So we just plug in our numbers, and we get the velocity of about 10.21 meters per second. Not bad.